Hey guys, welcome to lesson 4 of the True Beauty of Math. In this lesson we're going to talk about sets of sets, which is necessary mental machinery that we're going to need to start talking about the logical paradox that we're going to uncover in the next lesson, and also to start talking about the different kinds of infinities that we're going to see in the lessons afterwards. So let's dive right in. In lesson 2 we learned that a set is nothing but a collection of distinct objects. In this case, let me consider the set A, which is the name I'm giving to the set whose elements are the three elements A, B, and C. Okay? Now, A, B, and C here are just the elements of some set A, and they can be any kind of objects that we want. And so there's nothing stopping us from considering the possibility that a set itself can be viewed as a single object making up the elements of some other set. For example, I can consider the set, which I'll call creatively set, whose elements are sets. Namely, I can consider the set whose elements are the set 1, 2, the set 3, 4, and the set 5, 6. Now, it's important to distinguish two things. One, these nested brackets are here to tell us that we have a set, which I'm calling set, whose elements are themselves sets. We now need to also distinguish this from the set, which I'll call num, maybe as short for numbers, whose elements are 1, 2, 3, 4, 5, and 6. Namely, num has 6 elements, the numbers 1, 2, 3, 4, 5, and 6. Set, however, has 3 elements. One element is the set 1, 2. Another element is the set 3, 4. And another element is the set 5, 6. And that's just how sets of sets go. They're just sets whose elements are other sets, hence the name sets of sets. Now, there's a very important kind of a set of sets, which we call power sets, which are built up from other sets. Namely, let's consider the set A equals 1, 2. So this is a different set A than what I called A over here. I'm now calling the set whose elements are the numbers 1 and 2 the set A. We can consider the power set of this, which is nothing but the set of subsets of A. Namely, if we denote the power set of A by P of A, which let me remind you is nothing but notation naming the set of subsets of A. So P of A is a symbol naming some set, just like A is a symbol naming some other set. We now want to list all the subsets of A. Well, one subset of A is the empty set, because we learned in lesson 3 that the empty set is a subset of every set. Another subset of A is the set whose only element is 1. Another subset of A is the set whose only element is 2. And finally, the last possible subset of A is A itself, namely the set whose elements are 1, 2. There are no other possible subsets of A. Therefore, this is a list of all of the subsets of A. And we're grouping them together in a set which we're calling the power set of A. This set has 4 elements: the empty set, the set whose element is just 1, the set whose element is just 2, and the set with 2 elements, numbers 1 and 2. And these form all of the subsets of A. So the elements of A are 1 and 2, and the elements of the power set of A are subsets of A. For more details on power sets and sets of sets in general, which we'll need in order to discuss the next lesson, which is one of the most famous logical paradoxes that mankind has ever uncovered, and to go on to start studying different kinds of infinities, you can read the written lessons, which are either given below or linked to below if you're watching this on YouTube. And for even more details than that, you can, as always, check out the book True Beauty of Math, Volume 1, where we talk about these things in Chapter 3. So, I'll see you in Lesson 5.